I'm going to start this lesson going over those last three examples from yesterday. I don't know what some of you guys put. A lot of you had correct answers, but with mysterious work in between. So when you have 32 and 4, you had to realize that you could write both of those numbers as a base of 2. So the 32 I rewrote as 2 to the 5th power, 4 was 2 to the 2nd power. And then I brought the x down outside the parentheses. I don't know what people had with adding these. You didn't add them. So one person might have done it and some of you got it from them. The base comes down 2 and then multiply the inside-outside powers. That's how you get 5x, from multiplying them. Then I drop the bases, 5x equals 2, divide both sides by 5, you get 2 over 5. So this is in my Google Drive too now. 27 and 9 were both able to be written with a base of 3. 27 is 3 to the 3rd, 9 is 3 to the 2nd. Bring down the powers that were there, multiply the inside and outside powers, that's how I got 3x and 2x plus 4, distributing. Drop the bases, set the exponents equal. When I minus 2x on both sides, I get x equals 4. The last one was more challenging. 1 over 49 and 2,401 were both able to be written as powers of 7. 49 is 7 to the 2nd power, so 1 over 49 would be 7 to the negative 2nd power. And then I brought down the exponent that was there. 2,401 is 7 to the 4th power, and then I brought down the exponent that was there. Multiply the inside and outside powers. Then I was able to drop the bases, set the exponents equal, and I ended up with an answer. If I divided by 6 on both sides, one of you had kept it negative 22 over 6. That's fine. I simplified negative 22 divided by 6 is the same thing as negative 11 over 3. Now we're moving on to growth and decay. So the do now, pause this and answer on your own, because this is review from earlier in the topic before the graded assignment. Indicate whether each function represents growth or decay. So do you remember how we determine that? From the base. If the base is greater than 1, it's growth. If the base is between 0 and 1, it's decay. So looking at these 6, you have to first determine what the base is. Number 1, the base is 0.5. That's between 0 and 1, so it's decay. The next one, the base is 1.5. Greater than 1, so that's growth. You could also graph each of these. That's what we did earlier in the topic for the lesson. You could check it by graphing it and seeing, does the graph go up or does the graph go down? The next one, the base is 3, just the number that has the exponent over it. 3 is greater than 1, so it's growth. Number 4 has a 4, so it's growth. Number 5 has a base of 2/5, which is between 0 and 1, so it's decay. And then there's another fractional base here, 4 over 3, but 4 over 3 is greater than 1 because it's an improper fraction, so it's growth. Now, talking about exponential functions in terms of growth and decay, how we would write the equations. So here's your general form, and I'm going to be referring to this general form a lot. The a, which is the coefficient in front of the base, is the initial amount before measuring any growth or decay. Your r that gets put into the base is the growth or decay rate, which is given as a percent, but you must change to a decimal before putting it into the equation. And lastly, x is going to be the number of time intervals. So if this looks familiar to you, we covered this in algebra, so when you were in 9th grade. Here's an example of growth and decay. In the first example, the b is greater than 1, so it is growing. Here we have a situation where you're starting at 1, that's your coefficient. It's very close to the x-axis, so you can't see. n is increasing by a factor of 2 each time interval. Here, we're starting at 100. Since the base is between 0 and 1 with 0.5, it's going down. And it's going down by a factor of 1/2. So it goes from 100 down to 50 to 25 and so on. So this is what we have as exponential growth versus exponential decay. So we're going to be using the calculator and those formulas. The table below represents the number of people who are living in Funtown, New York. Well, what's happening to Funtown, New York? As the years since 2000 went up, the population in thousands is going up. So we have 4 choices, and I could plug each of these equations into the calculator and find the equation that way. However, I want to see that you guys could understand how to write this as an exponential function. So I would put, in this case, they're putting P at T equals, and then we have A, B to the x power for an exponential function. So already 2 of the choices aren't even exponential functions. Choice 3 is 3t, that's a linear function. And if you look what's going on here, to go from 1 to 3 and 3 to 9 and so on, it's going up by a factor of 3. So if you're multiplying by a factor of 3, that's an exponential function, not a linear function. Choice 2 has a squared. What type of function has an x squared in it, or in this case a t squared? Quadratic. It's not going to be a quadratic function. So we know it's an exponential function. It starts at 1 here, and it's going up by a factor of 3. So if it starts at 1, that means that the a is 1. If it goes up by a factor of 3, that's your base. And I should have put to the t power, not the x power, because they were using t in there. So which choice is that? Choice 1. Again, if you put choice 1 in the calculator, 3 to the t power, you'll see that the table of values matches. If you put choice 4 in there, it is not going to match. Okay. Now, number 2, all 4 choices, just looking ahead, are exponential functions. But we need to figure out which one describes this situation. According to the U.S. Census Bureau, which is actually relevant right now with the census going on, there were approximately 7 million households with access to computers in 1984. Computer usage in the United States from 1984 through 1997 grew at a rate of approximately 14% per year. Grew. I'm teaching. Shh, out. Grew, so it's going to be going up. So looking at my 4 choices, if I look at the bases, I can now eliminate 2 of the choices. Out of here.
Out of here.
I could eliminate 2 of the choices here that are not representing growth.